Greetings, my statistics friends. This video covers chapter number 9, linear regression, and the statistics involved in the linear regression model. This is for question number 4, which corresponds to 9.2, number 8 from your homework in section 9.2. So we are given some information obtained from a cattle ranch, and there are calves for sale, and they're going to buy some from the herd, and these are calf weights. So let X be the age of the calf in weeks, and let Y be the weight of the calf in kilograms. So for example here, we're given this ordered pair 3, 42. So X is equal to 3, Y is equal to 42. So 3 would be 3 weeks old calf, weighs 42 kilograms. 5-week-old calf weighs 46 kilograms, and so forth. So they're also then did a bunch of those calculations for us. So it took the sum of all the x's. So if you added up 3, 5, 11, 16, 26, and 36, you'd get 97. And the sum of the y's, if you added all those numbers up, you'd get 610. And then this is the sum of x squared. So 3 times 3 is 9, and 5 times 5 is 25. So you add 9 and 25, and then plus 11 squared, plus 16 squared, plus 26 squared, plus 36 squared. You get this value. And the same for the sum of the y squares. And then there's the sum of the x times y. So x times y be 3 times 42 plus 5 times 46 plus 11 times 72, and so on for all of those, and you get this this value. And then there's also this R coefficient. So this is a value that tells us mathematically how well a line fits within all of these data points. That is a mathematical correlation. Okay, so the first thing we have to do is plot these on the graph. So I need to plot the point 342. Well, I click the dot, and then I just stick a spot somewhere over here, and that's not exactly 342. So what I do is go over to point, and I change it to make sure it says input 3, output 42. Then I don't have to worry about being in the right spot all the time. And then I hit enter. And then I'm going to plot another point, which is 546. So I click that, and I change it to 546. And I do that for all of the points. Okay, so now that I have all the numbers placed in, this is what those look like on the scatter diagram. And I am attempting to find a line that best fits all of these points. But you can see this is not exactly a straight line, and so that's the idea of the regression line, or the least squares line. And least squares is referring to the minimum distance between all of these points. The absolute easiest question that we have is part B. So part B wants us to verify those, and you can certainly do that. But those numbers are the same numbers that are up here. So when you verify them, you should get these numbers. So the sum of x is 97, and you can verify that. And the sum of y is 610. Formula for the r, I'll let you look that up in your book, but when I find that, I verified that to be 0.999. Okay, part C, find x bar and y bar. So one thing I want to point out here is this is my least squares line, this y hat is how we say that, and then a plus bx. Now we are used to usually when we see an equation of a line in the form mx plus b, where m is the slope of the line and then multiplied by x, the variable, and then plus a constant, right, which we usually call b. So that's all this is. It's just written in a different form. So b in this case is the slope. So slope times the variable plus a constant. And they just decided to put it in this other form, a plus bx, but this is really mx plus b that we've been used to all these years in math class, so that's nothing new. So this x bar and y bar we have to find, and then we're going to use our calculator to tell us this value for a and this value for b, and we'll put the value for a here and we'll put the value for b there. So let's find this x bar and y bar, and remember that's just the average, right? So x bar is just the average of these x values and y bar is just the average of the y values. So on my calculator I have already put in the stats list menu the x values in list 1 and the y values in list 2. So I want to find the x bar and the y bar, and there are lots of ways that I can do that. I want to find the average of the things in this list for x bar and the average of the things in this list for y bar. Lots of ways I can do that. So one way I can do it is go into the stats menu and over to calculate and then do two variable statistics. And when I do two variable statistics, it says you put the x list in L1. So I put the x statistic in L1, and I put the y information in L2. And I'll leave my frequency blank, and I'll go down to calculate, and it will tell me all that information again. X bar, the sum of the x's, the x squared. It also tells me the sample and the standard deviation and the population standard deviation. And then it tells me y bar and the sum of y's and the sum of y squareds and so on and so forth. So that's the information. So I type that in, and then now it's asking me for this a plus bx, right? So I have to find the a and put it here, and the b and put it in the second blank. So how do I do that? Well, there are a couple ways to do that as well. But the way I'm going to do it is go back to my statistics menu, and I'm going to go over to calculate, and I scroll down to linear regression. That's linreg. Now if I do this linreg, it's going to tell me ax plus b, which is different, right? I want to go all the way down to the a plus bx, so that matches exactly what my textbook is. So this is the constant plus the slope times the variable. So that's the one I'm going to choose. And I put my x stuff in L1 and I put my y stuff in L2. And I'm going to leave my frequency list 0. And I don't necessarily want to store my equation anywhere, so I'm just going to go calculate. And when I do that, it tells me in that form, a plus bx, it tells me that a is equal to 22.5759 and b is equal to 4.8922. And so I'm going to go back to my problem, and this is the a value to 3 decimal places, so 22.576. B value to 3 decimal places is 4.892, so 4.892. Okay, there's another way to do that. Let me show you a different way. So I could also go to statistics and go over to test. So the first way we went to calculate and then down to number 8. I could also go to test and go down to the linear regression t-test or the linear regression t-interval. So if I do the linear regression t-test and hit enter, again I put the list L1 and the y in L2, so x in L1 and y in L2. And I want my frequency to be 1. And this beta and this funny looking p are something that we'll need for a different exercise, but for right now it doesn't matter which of these 3 I choose. And then I'm going to go down to calculate, and here it tells me again y equals a plus bx, and it tells me what the a is and the b is. So this is another way you can do it and save yourself a step or two when you're doing these types of problems down the road. Okay, so those are the same numbers, so I'm going to put those in. I already put those in. So then I want to graph the least squares line. So basically I'm going to graph this line, right? That's what I'm doing. So the slope of this line is positive. Remember, this is slope. The 4.89 is slope. So my slope is next to the variable. The b value in this case is the slope. So the slope is positive, so it's not going to be this one, and it's not going to be this one. Those two have a negative slope, so it has to be one of these two. And my y-intercept value, which is the same as this constant a, my y-intercept value is 22.57. So I have to find positive slope with a y-intercept value of 22.5. So it looks like it's this one. It wouldn't be this one, right? This has a positive slope, but the intercept value is way above 50. So it has to be this one. So this is my regression line. And then it asked me to find the coefficient of determination r squared. So what is the coefficient of determination r squared? Well, we take this r value that we were given, this 0.999, and we square it. So let's do that. So 0.999 and then squared equals 0.998 to 3 decimal places. So I enter that in, 0.998 to 3 decimal places. And then it wants to do the explained. Well, the explained is the same as the r squared. So this is 0.998 is explained, but they want it in a percentage. So I have to multiply it by 100%, or multiply it by 100 to get percentage. So 99.8% is explained. So 99.8% is explained. And then the unexplained would be 1 minus 0.998001. So 1 minus the explained. So this is the explained, 1 minus the explained, and I get that number, and I want to multiply that by 100%, or 100 to get percentages, and so that'd be 0.19% unexplained, and they want us to round to 0.2. So this would be 0.2% unexplained. And these two numbers should equal 100%. So 99.8% plus 0.2% do indeed equal 100%. So one thing that is important to point out here is that this r squared number and the coefficient of determination is how well the data or your line fits the data points. That's all it tells. It's a mathematical number that tells you how well your mathematical line fits the data points. So 99.8% of your model can be explained by your line. 0.2% of your model cannot be explained by your line. And that's what that means. Sometimes this gets over thought out, and people say, well, that number actually describes what's happening outside of the model, but that only describes the mathematical relationship, in this case between input and output values, nothing more or nothing less. Okay, so then it says the calves you want are 14 weeks old. What does the least square lines predict for a healthy weight? So what I do is write down my prediction model here. So 22.576 plus 4.892 times x. 4.892 times x. Well, in this case, you're asking about x is equal to 14, so you plug in 14 there and see what you get. So we're going to do 22.576 plus 4.892, and we're going to multiply that by 14 weeks because that's the x value they're asking about. So what should I expect a 14-year-old or 14-week-old calf to weigh? And the answer is 91.064 kilograms is what I should expect. And so it wants me to round to 2 decimal places, so 91.06 kilograms. Okay, I'm going to submit my answer and see how I did. Okay, so if you have any questions, please let me know.